Hello, this video is for IXL Activity A1.J.5. It is titled Solve Advanced Linear Equations. The 3-character code for this activity is 28 November. So on this one we have to do more than one step, have to do more than 2 steps, and we'll actually have to do multiple steps. So since we're doing multiple steps, 3 or more steps to solve the equation, they're calling these advanced linear equations. In the textbook, they were referred to as multi-step equations. And what we're going to find here, the extra steps that we're going to find is we're probably going to have to do some distributive property. You might have to combine some like terms. And then after that, after doing that, we'll probably end up with probably a 2-step equation on many of these. Maybe a 1-step, but for the most part, we'll combine some like terms, or we'll do some distributing using the distributive property, and then from there usually it'll be a 2-step equation. So after we combine the like terms and we do the distribution property, it's going to look a lot like the questions that we had over in the 2-step equations. So let's look at our first one here, and we have 3 minus n minus 1 equals 11. Well, let's do some combining like terms. We have terms of n here and here. Remember, every variable has a coefficient with it, and if you can't see it, it is the value of 1. It's the invisible one. Get it? So if I have 3 n's minus 1 n, I'm going to end up with 2n. So put our 2 in here. Let's go ahead and bring down the minus 1 and equals 11. And looky there, we got a 2-step equation, right? We're going to have to add 1, then divide by 2. So let's go ahead and do that. So negative 1, let's get rid of that with the positive 1. What we do to one side, we do to the other. 1's going to cancel each other out, leaving us with 2n on the left. And 11 plus 1 is 12. Now let's go ahead and divide each side by 2, and we're going to end up with n equals 6. If you're wondering if I went too fast from this step to this step here, go back and watch the video for the 2-step equations. We do that quite a bit. So I'm just going to go ahead and start jumping straight to that. Normally, I would have said 2n equals 12. We get rid of the 2 is tied to the n through multiplication. The opposite operation is division. Every fraction is a division problem that we're going to divide by the very number we wish to get rid of. What we do to one side, we do to the other. And the 2's cancel each other, and that leaves us with n, and 12 divided by 2 is 6. So that's all that right there is what I did from this step here down to this step right here. So if you're wondering what's going on between those 2 steps, go check out the videos for 1-step and 2-step equations. Okay, on this one here, I have t minus negative 15 plus negative 13 minus 3. Well, I see the minus and negative. That would be better as plus a positive, right? So let's go ahead, put this as t. Now we're going to take the subtraction, change the sign to addition, take the opposite of the value that follows. So the opposite of negative 15t is a positive 15t. And then we're going to go ahead and leave that as a plus negative 13 and equals 3. So let's go ahead and combine some like terms. We have terms of t both here and here, so we'll go ahead and combine those 2 different terms. So 1t, remember there's a 1 in front of that, right? So 1t plus 15t is 16t. And let's bring our plus negative 13 equals 3. And now we have a 2-step equation, right? So negative 13, let's deal with that by adding 13. And what we do to one side, we're going to do to the other. Adding that there. The 13's are going to cancel each other, leaving us with 16t. And 13 plus 3 is 16. Divide both sides by 16, and we're going to get 1. T equals 1. Remember, we can always plug our answers back into the equations and see if they generate a true statement. So if you want to, just to make sure, take the time, plug those back in. All right. U plus 16 over 4 equals 3. So one thing we know about fractions, the best way to get rid of a fraction, and that's not a 15, that is a 16. Hopefully, if you've been watching enough of my videos and taking my class long enough, you know that by now, best way to get rid of fraction, multiply by the denominator. So we're going to take this here and we're going to multiply by 4. And what we do to one side, we're going to do to the other. The 4 is going to cancel each other, leaving us with u plus 16 equals 12. And see, after that step, all we have left is just a one-step equation, and that is to subtract 16. What we do to one side, we're going to do to the other. 16s will cancel each other, leave me with u. And 12 minus 16. So if you're on a number line and you're thinking, oh, I'm at 12 here, and I'm going to subtract 16, right? Well, if you're taking away 16, it's going to take you past 0. So 12 of it's going to get you to 0. That would leave you another, 4, right? So you're going to be down here at negative 4. So 12 minus 16 is negative 4. Another way to look at that is 16 minus 12 is 4. The 16 has the negative 16 has a greater absolute value, and it's negative, so our answer is going to be negative. So it's negative 4. All right, well, here we have another one. Negative 2 equals p minus 3 over negative 2. Best way to get rid of a fraction, multiply times the denominator. So we're going to multiply both sides. Put that in parentheses there. Multiply both sides by negative 2. Negative 2 times negative 2 is a positive 4. The negative 2's are going to cancel each other, leaving me with p minus 3. Now I just have a one-step equation, right? Let's go ahead and add 3 to get rid of that negative 3. What I do to one side, I'm going to do to the other. And that's 3 is going to cancel each other, leaving me with p. And 4 plus 3 is 7. So p equals 7. Distributive property here. Actually, there's two ways we could work these. And I'm going to show you what I think is the more difficult way and what they're thinking that you're probably going to do. And then I'll show you what I think is an easier way to do these problems. So we have negative 2. Actually, it needs to be distributed into the j and to the positive 15. So let's go ahead and do that. Negative 2 times j is negative 2j. And negative 2 times positive 15 is a negative 30. And then let's bring down our equals 6. So that was the first step, to distribute that in. Now we have a two-step problem, right, from there. So it's going to be 3 steps in all. Distribute, add 30, divide by negative 2. So let's go ahead and add the 30. What we do to one side, we're going to do to the other. 30s are going to cancel each other, leaving us with negative 2j on the left and 36 on the right. Now let's go ahead and divide by negative 2. It's going to leave me with just j over here. And 36 divided by negative 2 is going to be what, 18, right? And that was a positive divided by negative, so that's going to be negative 18. So negative 18 is our answer there. Well, let's look at another way to do this. What if we had, let's go ahead and rewrite this. Negative 2 times the quantity of j plus 15 equals 6. Well, if I had negative 2x equals 6, you'd be like, oh, I could divide by negative 2, right? And so, because that's negative 2 times something. And what's left? The x, right? That would be negative 3, right? So what's left over is whatever the x is. So notice I have negative 2 times the quantity of j plus 15. Well, j plus 15 is a quantity that is being multiplied times 2. So I can go ahead and divide by negative 2 at this point right here. The negative 2's will cancel each other, leave me with j plus 15. And negative 6 divided by 2, it's going to be negative 3. And now, whenever I subtract 15 from each side, actually I'm adding a negative 15, correct? So those are going to cancel each other, leave me with j, and negative 3 plus negative 15 is going to be negative 18. So personally, on something like this, whenever I spot this, I would normally just go ahead and divide both sides by negative 2 so that I can end up with just the quantity of j plus 15 by itself that way, instead of doing the distributing the 2 in. So I'm going to go ahead and do this next one that same way. So negative 4 times the quantity of f minus 18 equals negative 4. So let's go ahead and do that. This is negative 4 times something, right? F minus 18. So I'm going to go ahead and divide by negative 4, and what I do to one side, I'm going to go ahead and do to the other. The negative 4 is going to cancel each other, leave me with just what's here in the parentheses. f minus 18. And then negative 4 divided by negative 4, negative divided by negative is positive, 4 divided by 4 is 1, so that is a positive 1. Now I can go ahead, add 18 to get rid of the negative 18. What I do to one side, I'm going to do to the other. The 18s will cancel each other, leave me with f on the left and 19 on the right, so f equals 19. So either way you want to do it, you could have distributed the negative 4 into the quantity of f minus 18 and then worked it that way, but I prefer to do it this way. I think it's a little bit easier that way. Well, definitely some combining like terms here. We have a term of y, and y. Why? So we all want to know why. So 19 minus 11 minus 7. So let's look at it this way. If we have 19 and we subtract 11, then we're going to get down to what? 8. And then if we have 8 and take away 7, we're going to get down to 1. So we end up with just one y, correct? Now, let's not forget the minus 1 here. Minus 1 equals 5. And then y minus 1 equals 5. So let's go ahead and add 1 to get rid of the negative 1. What we do to one side, do to the other. 1's cancel each other. Y equals 6. You can plug all that back in to make sure. And I'm double checking. Let me see. That's negative 11, negative 7 equals negative 18, which is minus 18. 19 minus 18 is 1. Yep. I want to double check that. That's the way I normally would have done it. I would have just done all that in my head. All right. This one here is kind of tricky. We saw this in the textbook lesson. The opposite of the quantity of g plus 4 plus negative 5 plus or equals negative 15. So what we want to do here is we want to imagine a 1 being squeezed right in between the negative sign and the 1. So I'm going to rewrite that as negative 1 times the quantity of g plus 4 equals, or plus 5, or negative 5, equals negative 15. So I haven't changed the value of this at all. By sticking that 1 in there, I can do that. You just kind of picture that. There's a 1 in between the negative sign and the parentheses there. That is to say, between the negative sign and the quantity of g plus 4. So now we see, oh, I could distribute this in to the g into the positive 4. So negative 1 times g is going to be negative g. Negative 1 times positive 4 is going to be a negative 4. So I kind of like the idea of plus a negative 4, right? That'd be the same as minus 4. So this is a value of negative 4 there. And then plus negative 5 equals negative 15. Whole lot of negative numbers there, right? So let's leave the negative g alone for now. And if you think about it, I want to go back for just a moment. If you think about this negative sign and think of the negative sign as the words opposite of. If you kind of think of the negative sign, the opposite of g plus 4. Well, what's the opposite of g? Negative g. What's the opposite of 4? Negative 4. So you could also think of it that way. I personally always think of it as this negative 1 being there and then distributed in. So however you want to approach it. Great. So negative g, and then we're going to add that to negative 4 plus negative 5 is going to be a negative 9 equals negative 15. Now let's go ahead and get rid of this negative 9 by adding 9 to each side. We do to one side, we're going to do to the other. That's going to cancel each other, so we end up with just negative g equals. And then negative 15 plus 9. Well, we're dealing with two integers. One's positive, one's negative. So let's take the difference of them instead. 15 minus 9 is 6. And the 15 has the greater absolute value. The negative 15, that is, has a greater absolute value. So we're going to use the matching sign. So this is going to be negative as well. And if we think of that on the number line, if we're at negative 15, and we're going to add 9, it's definitely not enough to get us back to 0, so we know we're going to land someplace here in the negative numbers, and that number's going to be negative 6. All right, got some decimal stuff going on here. I wonder if we could, let's try this. negative 49.12 equals 8 times the quantity of C plus negative 9.23. Now I could distribute that C in there, but I'm going to grab my calculator because I'm dealing with decimals and I don't want to do those mentally. So on this one here, I need to, the 8 is being multiplied times the quantity of C plus negative 9.23. So let's go ahead and divide by 8, right? Like that strategy we used in those other problems. And let those 8s cancel each other out so that on the right, all we have is C plus negative 9.23. And then let's take that negative 49.12. We're going to divide that by 8. And we're going to get an answer of negative 6.14. So now we have negative 6.14 equals C plus negative 9.23. So we can get rid of the negative 9.23 by what? Adding 9.23. And what we do to one side, we're going to do to the other, plus 9.23. These are going to cancel each other out, leave me with just C on the right. And then negative 6.14, add to that 9.23, and I am going to get a total of 3.09. So C equals 3.09. On this one here, I have T plus 2.1 over negative 4 equals 4.1. So what do we want to do to get rid of the fraction? Hopefully you're saying multiply by the denominator. And what we do to one side, we're going to do to the other. Negative 4 is going to cancel each other out, leaving us with T plus, was it 2.1? 2.1. And then 4.1 times 4. Actually, I'm going to do that 4.1. And I need to multiply that times negative 4. It's going to give me a product of negative 16.4. Now I need to get rid of the positive 2.1 so I can isolate the variable t. So let's subtract 2.1. And what I do to one side, I do to the other. I'm actually adding a negative 2.1, right? So subtracting is the same as adding a negative. And so these are going to cancel each other out here, leaving me just t on the left. And then negative 16.4, and I'm going to add to that a negative 2.1. It means it's going to get even more negative. So it's a negative 18.5. I probably could have done it without the calculator, I suppose, but 18.5. I think I have one more problem here. Indeed, I do. So how might we want to, oh, I see something that would work really, really well on this. Right now I'm thinking, do I want to distribute this 3.02 in? And I could go ahead and try to divide it out, but I got this 1.3 sitting here as well over on the left side. So I'm thinking, well, no, I might want to go ahead and distribute that in. But then I notice, wait a second, over on the right I also have 1.23. So let's try this. Take 3.02 times the quantity of V plus negative 1 and plus 1.3 equals 1.3. Well, you notice these two numbers are like the same. So let's go ahead and subtract 1.3 from the left and subtract 1.3 from the right. These are going to cancel each other out and leave me with, nothing. Well, what's the number we use for nothing? 0. So we have 0 over here. These are going to cancel each other out here, and now I have 3.02. I better move that over a little bit. Let's go backwards. Let's put the parentheses here, put the V plus negative 1 here, and the 3.02 here. Now, we know that this has to equal 0 right here, right? In order for, because anything times 0 is 0. So we know that whenever we take this 3.02 and we make it equal, and we want it to equal 0, whatever's in the parentheses is going to have to equal 0. And I guess I could go ahead and do this the traditional way. Let's go ahead and divide by 3.02. We do to one side, we're going to do to the other. It looks a little different working with the 0. It seems a little strange for some reason. But we'll cancel those out and we'll end up with V plus negative 1 equals, and then 0 divided by 3.02 is still 0. And so now you'll see exactly what I was saying, is that whatever's in the parentheses is going to have to equal 0, because we see now what do we have? We have v plus -1, which is what is in the parentheses, and indeed it does equal 0. So let's go ahead and that's a -1, so let's add 1. And what we do to one side, we do to the other. The -1, +1 cancel each other, leave me with v, and 0 plus 1 is 1. V equals 1. All right, so that's all I have for my examples of IXL A1.J.5 Solve Advanced Linear Equations. Good luck with your activity.